Hello, welcome back. We're going to leave the algebra tiles behind, and now we're going to move on and work on completing the square just using the algebra without the tiles. Before we do, what do you get when a dinosaur steps on your foot? What do you get when a dinosaur steps on your foot? So let's look at, again, think back, imagine in your mind those algebra tiles, and I want to complete the square on x squared plus 8x. Okay, so again, we know right, remember, we were always using half of this, weren't we, on each side? So this would be x plus 4 squared. That's what my square would look like. Okay, again, if we do a quick sketch, not quite algebra tiles, x plus 4, that's x, that's 4, that's x, that's 4. Do you remember what our algebra tiles look like? Okay, so that's x squared, that's 4x, that's 4x. And so we're missing something, aren't we? Because if I expand x plus 4 squared, I get this whole square, but I'm missing something. Okay, so what do I need there? Okay, so usually I would have 16 here, right? Okay, but I don't have the 16 squared. I just have x squared plus 8x. So if I complete the square by doing x plus 4 squared, I end up with this whole thing over here. But I don't want those 16, so what do I need to do? I need to take away 16. So I've completed the square, right? I have x squared plus 8x. I want to complete the square. I end up with x plus 4 squared minus 16. Okay, because think about what would we do? We would add the 16 we needed to fill in there, but then I would have to have the minus 16, right? This is the same as plus 16 minus 16. Okay, we use the plus 16 to fill in, and then I have the minus 16 there. So this is how we complete the square without the algebra. Or I'm sorry, without the algebra tiles, just doing the algebra. Okay, so I told you when we complete the square, we just focus on the x squared plus 8x bit. So again, let's look at this generically. What if I have x squared plus bx? Okay, b stands for some number. How am I going to complete the square? Okay, well, to complete the square, it's always going to be x. It's going to be half of b, isn't it? It's always going to be half of b, and then that thing squared. Okay, and then what am I going to need to do? I'm going to always need to take away b over 2 squared. Okay, and if you look back at your algebra tiles, you'll see why that is. We'll do some more examples so you can see why that works. Look at the example we just did here on the left. Okay, I did half of 8 to go there. Okay, and then I had to take away the 4 squared. Why? Because I had to add on 4 squared to complete the square. And this will always work. This is sort of like a formula for how we complete the square. So let's look at our next example. X squared plus 6x. Okay, this is, remember, x squared plus bx. How do we complete the square? It's going to be x plus b over 2 squared, right? So it's going to be x plus 3 squared. Okay, and then I'm always going to have to take away b over 2 squared, always, always, always. So that means b over 2 is 3, so we need to take away 9. Okay, why is this? Again, think back to our tiles. X plus 3, x plus 3, that's x squared, that's 6x, that's 6x. I need to add 9 tiles, don't I, to complete the square. All right, in order to complete the square, in order to do this, I have to add in 9 tiles. Okay, didn't get a chance to finish that last one, but we'll continue on. You had the idea this time. So again, remember, right, it's x squared. This time, I can still write my rule as plus bx. And what is my rule? It's always x plus b over 2 squared minus b over 2 squared. So this time b is minus 4. So half of minus 4 is minus 2. So it's going to be x minus 2 squared. That's the completing the square bit. Okay, but again, I need to do this minus b over 2 squared. So minus 2, so I need to minus 2 squared is 4. So I'm taking away 4. And again, Go back to our tiles. That's x minus 2, x minus 2. That's x squared. That's minus 2x minus 2x. All right? And think back, how did we complete the square? I needed to add 4 in here, didn't I? I needed to add, actually let's do them in yellow because that's how we did them with our algebra tiles, right? I needed to add 4 positive tiles there to make the square. But if I add 4 positive tiles, what did I need to do? I also needed to add 4 negative tiles. That's where that negative 4 is coming from. So this rule will always work. Again, you can always check it, expand this, and you should get x squared minus 4x. Okay, let's look at one more example again. If I have x squared plus bx and I want to complete the square, it's always going to be x plus half of b squared. That's the square. Okay, but in order to complete the square, right, in order to complete the square on this, I need extra tiles. I can't make a square. How many tiles am I adding? I'm adding 9 tiles, aren't I? If I add 9 tiles, I need to take away 9 tiles. How do I know it's 9? Because it's half of 3 squared. So if I complete the square on this, it's going to be x minus 3 squared because it's half of b. b is minus 6. Okay, and then what's minus 3 squared is positive 9, so I need to take away 9. Again, imagine our picture with our algebra tiles. That's x minus 3, x minus 3. All right, this is how we made the square for x squared minus 6x. I had x squared minus 3x minus 3x, and I was missing some pieces. So what did I need to do? I needed to add 9 pieces here. All right, I had to add 9 pieces so that I could make a square. But if I add 9 pieces, I can't just add 9 pieces. If I add 9 pieces, positive pieces, I have to also add 9 negative pieces. Okay, that's why I'm taking away half of b squared. It's always, this number squared is always what I'm subtracting because I'm always going to have to add pieces to make a square. Okay, so the question was, what happens when a dinosaur steps on your foot? You get ankylosaurus. So I'm going to give you some questions to go ahead and practice on your own.